Today I am going to talk to you about universal time and the velocity of light. I will be discussing three postulates on the velocity of light. The 1905 Einstein postulate, which we will call postulate 1, which says that the velocity of light in free space is always a constant c, irrespective of the motion of the source or the receiver. As you have heard, this postulate was not readily accepted, and one of the most brilliant young men at Göttingen, a Swiss named Ritz, suggested only 3 years later the postulate, which we call postulate 2. This is a ballistic type postulate. It says that the velocity of light in free space is a constant c with respect to the source at the instant of emission. This is the postulate we have heard discussed in the last paper. In the 1950s, Professor Moon and I began examining these questions, and we studied the Ritz postulate and the binary star evidence, and then we went on to do a paper in 1956 in which we discussed the question of how one could establish universal time. That is, how could you synchronize clocks between two observers who were, say, on Earth and in a satellite, who were in motion relative to one another. And when we studied this synchronization process, we discovered that we could not synchronize clocks with Einstein's postulate and could sometimes synchronize in general. I will come back to this question in a moment. And could more often synchronize clocks with Ritz's hypothesis, but we said universal time is an awfully nice concept. Intuitively, we like it. It would be nice to keep it. Is there any way that we can keep it? And considering motion in a straight line in this first paper, we developed the conditions under which universal time could detect even for accelerated motion. Postulate 3 says that in any coordinate system in which the light source is stationary, the velocity of light in free space is a constant c. That doesn't sound like a postulate that most physicists would quarrel with. They are ordinarily working, in most cases, in an environment in which their source is stationary in their laboratory. And this says the velocity of light is the constant c that they ordinarily measure. Now, before I go into the experimental data for comparing these postulates, I want to try to give you some ways of visualizing them. One of the ways of visualizing them is this. Suppose that the receiver at time t is at point x, y, z, and the source at an earlier time tau is at a point whose coordinates, rectangular coordinates, in a arbitrary coordinate system of c, eta, and theta. Then you can express all of these postulates as we showed in our 1989 paper, in which our son also collaborated with us. You can show, or we did show, that all 3 of these postulates could be described by a single equation. The radius is c, times t minus tau. But you have to define the radius differently in these three cases. In Einstein's case, the radius is the distance from where the source was at the instant of emission to where the receiver is at the instant of reception. In Ritz's case, you have to use the point to which the source would have moved by time t if it had continued to move at the velocity that it had at time tau, and you come out with this τ2. While with postulate 3, the distance that must enter is the distance from where the source is at the instant of reception to where the receiver is at the instant of reception. I have another set of diagrams which come from Euclid Moon's paper, which was published in Physics Essays just within the last month, in which we showed the difference between these postulates. In Einstein's postulate, if you have a source moving along this path, this curved path, but here at the instant of emission, the light moves out in circles of radius c times t minus tau, which are all centered at where the source was at the instant of emission. While if you go to Ritz's postulate, the circles, the wavelengths, are no longer centered here. The first one is, but the next one is centered here, which is on the line tangent to the path at the instant of emission. And the third one is centered over here, again moving along the line tangent to the path at the instant of emission. While with postulate 3, we have again these three circles, but the center of this one is here, as in all three cases. The center of the next one is on the path along which the source is actually moving, and the center of this one, of the big one, is again on the path along which the source is actually moving.
All circles?
All circles. Now, let us consider the comparison of these. I will not consider all of the experiments in physics. I will consider the ones we have so far analyzed. And I point out to you that we have not analyzed everything yet. However, let us consider the questions that we believe we have studied thoroughly. From the original universal time table, we find that it is possible to synchronize clocks according to Einstein's postulate only for two laboratories which are not in relative motion, for stationary laboratories. According to postulate 2, one can synchronize clocks for any laboratories which are moving at a constant relative velocity, but they must be on accelerated laboratories. And for postulate 3, one can synchronize clocks for all laboratories. The fact that it is nice to be able to synchronize clocks does not, of course, prove that you can do it. It merely gives an aesthetic advantage of simplicity to the third postulate, which, by the way, you will notice reduces to Ritz's postulate if there is no acceleration. In the first paper that my son did, he analyzed the Michelson-Morley experiment. And I have a summary of the results here. We postulate 1. In the laboratory reference frame, you have a null friendship. In the laboratory reference frame, we postulate 2, you again have a null friendship. We postulate 3, you have a null friendship. Or, if you evaluate in the laboratory reference frame. But suppose that you analyze this experiment, sending light from here to here, and from here to here, and seeing if there is a friendship when the arms are equal and perpendicular. What happens? Suppose that you have a coordinate system which is in motion at a constant velocity relevant to the laboratory. Then, according to postulate 1, the two light beams come back at different times. And the only way that one can get around this is to follow Fitzgerald's suggestion that you can track the length in the direction of motion. This puts in a bugger factor, which is a function of velocity. If you use Fitz's postulate in a constant velocity reference frame, you get no null friendship, a null friendship, and in postulate 3, also a null friendship. If, however, you use an accelerated reference frame, then postulate 1 requires a Fitzgerald type contraction, which is a function of both velocity and acceleration, which we do not normally see discussed. Accelerated reference frame, postulate 1 requires a Fitzgerald type contraction, which is a function of both velocity and acceleration. Postulate 2 requires a Fitzgerald type contraction, which is a function of acceleration, and only postulate 3 predicts the correct result. Therefore, we can say that the only postulate of light which predicts the experimental null result in all reference frames is postulate 3. Now let us review the data on binary stars. I might interject a note that makes de Sitter's work even more interesting to me. My thesis advisor, Del Stroy, was a student in de Sitter's class in astronomy at the time when he was publishing his papers, which essentially, in a half page or so, destroyed the Ritz postulate and made no one think of this, or hardly anyone think of this, after 1915. In 1953, we wrote our first paper analyzing the binary star data, and in 1989, we published another paper in which we analyzed it in a more thorough fashion, using the most recent advances, namely analyzing it both in terms of postulates 1, 2, and 3. In 53, we didn't have postulate 3, and so we analyzed the data for the Einstein postulate and the Ritz postulate. And what we found in the 53 paper was basically that you were into major trouble with the Ritz postulate unless you postulated that all of space is Riemannian instead of Euclidean. And if you made space Riemannian with an astonishingly small radius of curvature of about 15 light years, then you could get around data on the binary stars, which had been considered to be devastating to the rich hypothesis. There are really three kinds of data with the binary stars. The first is the Doppler shift, which, according to postulates 1 and 3, this is always small. According to postulate 2, it is sometimes infinite. But Doppler shifts are always small. Multiple images never can occur with postulates 1 and 3, sometimes occur with postulate 2 unless you use the Riemannian space. But multiple images are never observed. So postulates 1 and 3 survive this, but not postulate 2. And then there is apparent variation in magnitude, which is nearly constant, and this is predicted with postulates 1 and 3, but it becomes periodically infinite according to postulate 2. We have then binary stars indicating that postulate 2 is not a good idea unless we wish to postulate that our space in the large is Riemannian. Then there are other experiments that have been analyzed. We did a paper on analyzing the Michelson-Gale experiment. In fact, this is what Professor Moon and I were discussing the last time that he was in the emergency room before he died. And we wrote down the modification postulate then, and it turned out to be right. We found when we analyzed the Michelson-Gale experiment that neither postulate 1 nor postulate 3 could explain this postulate. It was necessary to add the same 5 words to both postulate 1 and postulate 3 in order to explain the Michelson-Gale experiment. These are the words which is not in rotation. And after we had discovered this, I talked to Professor Stroik, and then he suggested I talk to the people at the Einstein Collection at Boston University, and they led me to the quotation from Einstein, which is here, and is essentially equivalent to this. Einstein in 1907 realized that his 1905 postulate should be modified, and that it was only if you have on accelerated forward systems that even Einstein believed in the constancy of the velocity of light.
What's the reference to that?
I have the reference in my paper. I don't have it here. If any of you want my copies of this paper, please give me your names, and I will send them to you. I have one copy here. I did not load myself down with 30 copies. The Saginaw experiment was also analyzed by the same procedures and found to be explained very nicely with postulate 1 star or postulate 3 star. Uma Sharma worked on this with us. The last of the problems that I want to talk to you about is stellar aberration, and then I will be done just about on time. If you analyze stellar aberration, there are 2 and 3 style all give the same cell and give exactly what is predicted. In 1728, by Griffith. My last slide shows the corresponding analysis in the coordinate system in which the telescope is stationary, and in that coordinate system, the postulate 1 style predicts no aberration, but postulate 2 and 3 style predict the correct aberration. And if you remember my second slide and this one, you will notice that this angle is precisely the angle between the radii that I showed you in the first slide. We therefore have the following situation to summarize. It appears to be possible, based on the experiments that we have hitherto analyzed, to explain all of them only by postulate 3. If this result remains valid, as I hope it will, our world is greatly simplified. Universal time is restored. The viewer of time, the viewer of standards, will no longer be considered to be lying every time you telephone them for the time when they say the universal time is. Universal time will be real. Of course, a great deal of work remains because Howard and all of you keep mentioning experiments that we have not yet analyzed, and we must do much more work. But tomorrow morning, we will show you what beautiful results we get if we do use postulate 3 in formulating electromagnetic fields. Things come out much more simply, much more beautifully, and there will be experimental evidence presented by my student Philip Mann, proving in a totally different way that